Vamos a seguir ahora con una ponencia que nos lleva al mundo de los materiales avanzados, en concreto a una solución desarrollada para entornos críticos en los túneles ferroviarios, donde la seguridad frente al fuego, la resistencia mecánica y el bajo mantenimiento son esenciales. Nos acompaña Günther Hirt, director general de FISCO, que nos presentará el sistema FIResist, que es una innovadora solución composite incombustible pensada para este tipo de aplicaciones. Günther, feel free to start.
Señoras y señores, buen día y bienvenidos a mi presentación. Speaking for the company FISCO, a part of the Fisher Group, I will give you a brief introduction to composites and in particular to incombustible composites. FISCO, what does it stand for? In 2 words, it's Fisher Composites. I said we are part of the Fisher Group and we are focusing on composites. When I speak about composites, I mean glass fiber reinforced polymers, and I mean carbon fiber reinforced polymers, and I talk about profiles. Let's start with why. Why composites in the construction business? So composites offer a wide range of material properties that are quite useful for construction applications. So all our products, they are developed combining a bunch of requirements. Material properties of composites are fitting quite well. So when we look at this picture, for example, and I've just mentioned here a few properties of composites, we see this barrier-free ramp made of a vinyl ester glass fiber composite system, enabling wheelchair drivers or other persons with restricted mobility to enter and exit trains quite smoothly and comfortable. Of course, thermal decoupling, for example, that's another big advantage of composites compared to other materials in the construction business, like steel or aluminum, for example, which we use for applications in the building envelope when it's about energetic, efficient way of building, which is not the case in this example. However, I would like to ask you to keep this picture in mind because I will return to it later on. Let's continue with the question, what? What do we do in FISCO? As said, it's about profiles, and that's the typical process of our value chain, which almost every product goes through. We start with the idea, we bring it through the development process, we industrialize the product, we bring it to life, we materialize it, we have our own production, everything is located at one site in Germany, and we bring it to our customer, and of course we also do support our customers with the assembly support on the construction side. But it's not about material only. The material is just means to an end. And that's one crucial criterion with regards to the positioning of FISCO. We always think in systems and we think in solutions. So what does the customer benefit from? One example, you see it on the very right-hand side, the black frame. That's a window installation system which we have invented, also with some items that are patent pending at the moment. And with this system, it's made of glass fiber profiles, but it's not about the profiles, it's about the solution. We save installation costs up to 75% in comparison to other similar solutions. So that's the way we provide a customer solution, and that's our understanding of an engineering accomplishment. Another example, and I will show this in detail later, is this platform for the railway infrastructure. So one part of the positioning of FISCO was solution orientation and a very strong application focus, being very close to the customer and being driven very technically, let's say it like that. And then we dedicated to another very crucial issue of composites, because composites, also glass fiber reinforced polymers, GFRP, they do inherently burn because they are made of a fiber component like glass fibers, like carbon fibers, like other fibers, and a resin, a matrix system, and this is an organic chemistry. So we said, why not develop an inorganic composite material? And we found out it's rather difficult. A lot of other companies tried to do so. Unfortunately, they failed. GFRP burns, ours does not. So finally, we succeeded in this development, and since this was a rather new material to the market, we decided to give it a name, and we call it FiResist, Fi for fibers, and then also the word fire resistant is inside this term. And I said to you, please keep in mind the picture I've shown to you before to illustrate what composites in construction are good for. So you see here, this is not on the outside, as shown on the picture before. That's inside a metro tunnel. That's the metro of the city of Munich. And there you have very strict fire requirements. So no combustible, no flammable material is allowed to be installed in this tunnel. They even think about changing the timetables from a paper print to an incombustible version. That's how strict they are. And we also installed our access ramps for the wheelchair drivers here, because they are made of our incombustible composite material. Why composites here? Of course, they need to be loadable. So wheelchair driver, for example, also with an electric wheelchair, should pass over it without any security issues. They need to be non-corrosive. But most particularly, as said, they need to be incombustible and electrically non-conductive, because there is the so-called third rail providing the electricity for the trains going right underneath the platform. So imagine a 10-meter ramp like this being made out of stainless steel. That's a huge danger in terms of an electrical spread over. But the area of application inside railway tunnels and metro tunnels is much larger, and I remember a very interesting discussion last night at dinner with part of this group for the C2F forum. We had an interesting discussion about the increasing demand of public transportation also in the city of Barcelona. That's a picture from the city of Berlin. You can see here an emergency exit platform made of wood. In Europe, there are approximately 4,200 kilometers of metro tunnels, and 1,650 need to be retrofitted within the next 10 years. So there are basically 3 stages in time, in different eras, where the metro tunnels in Europe have been built. One is in the early 1900s, before World War II. The second stage was in the 1950s to the 1970s, and the latest stage in the 1990s, but most of the new construction in the 1990s of metro tunnels, that has taken place in Asia. So when we speak of Europe, we speak mainly about retrofitting these tunnels, and you clearly can see on this picture the reason why. Of course, there's a lot of things to do within the electrical installation, but also with regards to such kind of platforms. Because a wooden platform, of course, it's very beneficial, it's electrically non-conductive, but it's combustible, so it needs to be removed. What other solutions are possible to meet the demands and the requirements for such a retrofitting for this kind of an emergency exit platform? Of course, it needs to be carried out quite fast, because you need to shorten the closing time. You don't want to have a huge effort for the construction side, so no heavy machinery, no heavy tools, no large amount of building materials. You have to install it quite quickly. Needs to be incombustible, as said, needs to be very light to bring down the material, and of course you want to save costs. In the end, it's always about costs. You have and you need to save costs for the installation process. And if we compare the typical materials used for such kind of installation with the criteria flammability, electrically non-conductive, lightweight, time for the installation, and in the end, what's the total cost of ownership? You see, steel, incombustible, but the other criteria are not fulfilled that good. With wood, as shown on the picture before, I think that it was installed in the 1950s. Everything works out well, electrically non-conductive, easy to install, so it goes fast, and it's not too expensive, but unfortunately flammable. Concrete, not flammable, electrically non-conductive, but definitely not lightweight. So it takes a long time to install, because you need to bring down all the material there, no matter whether it's concrete to be mixed on the construction side, or it's concrete blocks prefabricated. Takes a lot of time, need heavy tools, heavy machinery, so rather expensive. With GFRP, quite a good solution, and that's why such kind of platforms you find outside of metro tunnels or outside of railway tunnels quite often. GFRP works perfectly, but unfortunately they do burn, and with our material all these specific criteria are fulfilled. So I think I already explained to you what are the material properties, so I can go through this slide quite quickly. Also, we have a look at combustibility, conductivity, mechanical properties, the maintenance effort, the effort for on-site processing, and the weight. And you can see with these segmented fields, where are the strengths, where are the weaknesses. The farther on the outside in this diagram, the better the material is. Precast concrete blocks, as explained before, steel elements, common GFRP, and that's a platform on the outside, and that's quite common in the construction of railway infrastructure to have such GFRP platforms on the outside. You already see here, it's a rather completely filled out segment, so it's quite usable in terms of material properties, and with the fire resist solution, we can meet these demands quite comprehensively. And that's how the product program does look like. We have the platform with staircases, we have walkway, we have handrails, and we have railing. That's a computer-generated image, and that's how it does look in real life. That was during the InnoTrans trade fair taking place in Berlin in September last year, and that was the world premiere of this entire program, which now also has, by beginning of March, received the European approval from the Eisenbahnbundesamt, the German National Railway Authority. We are about to obtain the European technical approval as well, so this process is currently ongoing, and I hope within this very short presentation I was able to ignite a certain spark to inspire you, not only in terms of railway infrastructure, but also with regards to other applications where you could think of composites in the construction industry and maybe also of incombustible composites. I'm available for any discussion, so I hope this was of interest to you, and muchas gracias.
Do you want to stay?